In this video, I'm going to show you how I built this wireless motion control servo robot, which is a laser attached, which can be switched on and off remotely. It's controlled via two Arduinos, an Arduino Nano at the transmitter, which is in my hand, and an Arduino Uno, which you can see moving around. It uses an MPU 6050 accelerometer and gyroscope to sense the motion of my hands, and it uses an NRF24 LO1 wireless transceiver module to transmit the information wirelessly to the servos. Keep watching to learn more, and don't forget to like and subscribe. This is the wireless servo robot which I've made, and it consists of two microprocessors, one Arduino Nano and one Arduino Uno. The Arduino Nano is connected to an MPU 6050 gyroscope accelerometer, which picks up the motion of my hands. Then that information is transmitted wirelessly via the NRF wireless radio transceiver, and that information gets picked up by the second transceiver, which is on the servo robot end. That information is then decoded by the Arduino Uno and then sent to the servo motors to control the motion of the servo robot. So we have two servos at the robot which control motion in the X and the Y axis. Now let's have a look at a simplified diagram of how it works. This is a schematic of the wireless servo robot. The servo robot is in two parts. It has a transmitter and a receiver. The transmitter is the motion control portion and it's the remote control. The way it works is that it's controlled by a Arduino Nano processor, as you can see, and the MPU 6050, which is this portion, picks up the movement of my hand, transfers that information to the microprocessor, which then transmits that information wirelessly via the NRF24 transmitter. The information is transmitted wirelessly to the receiver. The Arduino Nano processor also has an on and off switch for the laser to control the laser, and it's got an external battery which powers the whole unit. On the receiver side, we have the servo robot itself. The servo robot is controlled by the Arduino Uno microprocessor, and it controls two servo robots which control movement in the X and the Y axis, and it has a receiver antenna to receive the motion data which is sensed by the MPU 6050. It decodes this information via the microprocessor, then transfers the information to the servos to sufficiently control the motion in the X and the Y axis. So let's have a look at the code which I've created for the transmitter. I use two libraries, the SPI and the Y library, and the main purpose of the code was to transmit the motion sensed by my hand wirelessly to the servo receiving unit. I use a serial monitor to track all the information that was being sent wirelessly. The serial monitor also allowed me to see whether I had any problems with my code. The information sent is represented by two numbers and a high or a low. As you can see, if I vary the pitch or the roll of the motion sensor, the two numbers change according to the amount of rotation in either direction. It would also change from a low to a high depending on whether I had the button pressed or unpressed. Here is the code for the receiver, where all the data is sent to be decoded into motion for the servos to move. The serial monitor shows information which has been received from the transmitter. It has three values again: button on and off for when it senses the button has been pressed or not, and two values for the roll and the pitch motions of the motion control. Once again, the serial monitor is just a useful tool to debug faults which could arise, such as the module is not communicating properly or something wrong with the code. Here is a simulation of how the MP6050 works. We have a 3D model of an aeroplane, and this is used to represent the gyroscopic accelerations felt by the MP6050 sensor. So if I vary the pitch of the sensor, this is replicated in the 3D model, the roll, and the yaw. This is the end of this video tutorial. I hope you enjoyed it and you got something out of it. Check out the other content on my channel. My last video was on pressure sensors. I'm in the process of making a brand new UDEMY video about how to make your very own servo robot, so look out for that. I hope to bring you more content in the future. Till then, please comment, like, subscribe and share.